Hi everyone, welcome back to the gas chemistry video series. So today we're going to be going over a second FRQ regarding the gas laws. This one was from the 2025 AP exam, and you can find it on the College Board website. College Board recently removed all past FRQs and like AP exam questions from before 2023. Um, but pro tip is that you can go search like a lot of people on different online forums have like downloaded them and distributed them because I think it's really unfair of them to remove that extra practice resource. So if you're looking for it, you can find it on there probably. This one's from 2025, so it will be available. Um, and so the question is complete the Lewis diagrams some and then it gives some physical properties for compounds X and Y. So I'm just going to zero in on this last part of the question. And oops, let me change the color of my pen. Okay, there we go. Because this is what's concerning gas. But what I wanted to highlight by providing this example is that questions about gases are rarely like the center point, or not that it's rarely the center point, but a lot of times it'll be like a subpart of a larger question. And sometimes it might like even interconnect with the answers to other questions. So it is a very important topic. Um, so you guys will probably cover VS EBR theory in like the mid-fall semester, boiling points and colligative properties in the spring semester, um, and vapor pressure as well in the spring semester. Okay, so this mixture of gases is heated to 198 Celsius in a sealed, rigid 12.5 liter container. And then, well, I guess, yeah, they are a mixture of gases because they've been heated to that high, but they were liquids before. And the total pressure in the container is 2.30 atm. Calculate the number of moles of gas particles in the container. So as we addressed in the last video, we're not looking for a change. We're given a ton of values and we're trying to find like a last property of this gas mixture from what we've been given. So we know we're using the ideal gas law, not like a relation such as Boyle's law. Okay, and this will be on your equation sheet, but PV equals nRT. And so you can either set it up by just plugging in the values and then dividing, but another cool thing you can do is just isolate n. So you divide everything by RT, and so you should get n is equal to PV over RT, with n being the number of moles. And that's going to be equal to plugging everything in. Just make sure that all of your values are with the correct units. So we know our gas is an ATM. Perfect. And then we know our volume is 12.5 liters. Liters is also perfect. And then we have our ideal gas constant, which is given on your formula sheet. They do it to like four significant figures. So 0.08206 ATM liters over mole Kelvin. And then finally temperature. So uh, it's 198 degrees Celsius, but we can use what we have on the conversion sheet to convert that into Kelvin. So 198 degrees Celsius, or is going to convert to, let me use my calculator. 198 plus 273.15, 471.15 Kelvin. Okay. And then you can just use your calculator. Make sure that you're rounding to the appropriate amount of sig figs, and also that you do actually plug in your values, because if you just write out the equation, you're probably not going to get, or you could get like dinged. Okay, 2 by 3 times. Okay, and so I got 0.74361, etc. But as you can see, the smallest amount of sig figs, so for here, the amount of sig figs would be 4, here it would be 5, but on the top we have two values that have 3 sig figs, and that's going to be our lowest number. So we round to that amount of sig figs. So in the end, our answer is going to be 0.744 moles. Um, and allow me to clear all this. Is there a faster way? There we go. Maybe there's not a faster way. Give me a second to erase this. Maybe if I just go to the next slide. Oh, perfect. Um, and here's the scoring commentary from the AP website. So they did it in the exact same way that I did it. They just rounded their Kelvin value, which is pretty much fine because we know that we were going to round to 3 sig figs anyways. And then here is the sample correct student response. So they did it the other way. They just plugged in the values and then they solved for n after, which works too, but observe that they actually plugged in the values. On the left side, I just have the answers to the other questions. This is just to highlight that there are a lot of explanation and writing questions. So even though gas questions tend to be more application heavy, unless you're talking about kinetic molecular theory, you will have to do a lot of explaining, and they do have a very specific rubric. So be careful. Like you want to make sure that if it's asking like a yes or no question, don't just explain like your why, make sure to say yes or no. And there's some other things, but that's why it is really important to look at the past student responses and see how they were graded. But that's it for this video. I'll see you in the next one. Bye.